to enhance UAS safety. I will now hand over to Christian Ramsey, President of Avionics. Over to you, Christian.
Good morning, everyone. Let's get this turned on so you can see both me and the presentation. This is a live presentation, and I will be sharing my screen. That looks good. Hi. Thanks. This is utilizing ADS-B to enhance UAS safety. I'm going to give a little bit of a background of what ADS-B is and how it helps with UAS integration. I am from Avionics Corporation. We're based in the United States. We have a UK subsidiary. I'm not logged into the platform right now. Please feel free to leave comments and questions there. I will log into the platform directly after the presentation to address any comments or questions. My email address is also on the screen here. Please feel free to reach out to me directly. All right, let's get started. So, one slide introduction to Avionics. We are an avionics manufacturer for drones and general aviation. We produce equipment that falls into the communications, navigations, and separation categories. So command and control radios, GPS position sources, and transponders and ADS-B solutions. These are some examples of what they look like for our drone solutions. So what is ADS-B? ADS-B is a technology that is an industry aviation standard. It involves equipment that resides on an aircraft that receives its GPS position and then broadcasts that GPS position for anyone to hear and recognize. The message that's broadcast contains latitude, longitude, altitude, and identification, state vector, and some intent information regarding where the aircraft is and where the aircraft is going. So you can imagine that this type of information would be incredibly helpful for detect and avoid applications. There are a couple of key items that are really important regarding ADS-B versus some other communications technologies out there. The first is that it is an international standard. And why is that important? That's important because this technology is being implemented worldwide through various levels of integration and mandates, general aviation and commercial aviation. Many thousands of aircraft already have this type of technology on board. And the second is that this is on common and protected frequencies. So if you're developing a technology, you really only have to listen to or transmit on 1 or 2 frequencies, and they will be globally applicable. So very useful from a drone detection or a drone detect and avoid perspective to be able to listen or transmit on 1 of 2 frequencies or 2 of 2 frequencies in order to be seen and heard and see other aircraft. These are some examples of Avionics, ADS-B avionics. These are not your typical avionics. They don't look like a typical piece of avionics that goes in a general aviation aircraft or a drone. That's one of our hallmarks. We tend to build and certify things in very small form factors, and doing so we can integrate ADS-B technology into things like the lights on the tail or wingtip of your aircraft. So what you might see from a typical manufacturer is something that's quite boxy. These designs are sort of specific to Avionics. They might look more like the bottom center piece of avionics there, but somewhat bigger. So see and be seen is something you often hear with regard to ADS-B technology. In the UK, there's a phrase called electronic conspicuity that we will get into, and see and be seen is a phrase that you hear often with that. There's a term called ADS-B-in, which is the C component of see and be seen. ADS-B-in means you have a receiver that you can receive other aircraft signals and decode them and understand where they are. The photos here are of 2 Avionics products. One on the left is Ping RX, the other is Ping RX Pro. These are ADS-B-in receivers that allow you to see other aircraft. ADS-B-in is a fantastic safety mechanism, as we'll talk about, for detect and avoid applications. There's another type of ADS-B called ADS-B out, and that means you can be seen. You are transmitting your position to other aircraft in the area. The combination of ADS-B in and ADS-B out allows you to be see and be seen. The product here is our Ping 200X Mode S transponder. This is an ADS-B out system. ADS-B out systems are not always appropriate for drones. They're typically only appropriate for large drones operating in controlled airspace, high altitudes, mixed use airspace, and not always for small visual line of sight, low altitude aircraft. The product that you see there, the Ping 200X, is a 250 watt transmitter. You will be seen hundreds of miles away if you're transmitting on that. So that's not always appropriate. And of course, the best of both worlds is devices that have ADS-B in and ADS-B out. Two examples here. One is called Sky Echo, which is a portable ADS-B in and out system for general aviation, and the other is a Ping 1090i, which is also a portable, an ADS-B in and out system for drones. The best combination is when all of your manned aircraft have ADS-B out and your unmanned aircraft have ADS-B in. That enables the safety net to take effect without crowding spectrum by transmitting ADS-B from all of the drones, but it allows your drones to see all of the aircraft that are flying with ADS-B out. So a little bit of a comparison section here of ADS-B versus other DAA technologies. There's a lot of technologies being invested in for detect and avoid. The primary concern is detecting aircraft that are non-cooperative or aircraft that do not have ADS-B on board. So ADS-B in itself is not going to be your only detect and avoid technology. You're going to need to combine it with other technologies to detect other aircraft that are not ADS-B equipped out. But as a comparison, ADS-B detection ranges far exceed that of other detect and avoid technologies by orders of magnitude. Like I said, hundreds of miles for some systems, whereas if you're looking at a radar or a camera-based detect and avoid system, you're really only looking a couple of kilometers out and barely meeting that well clear definition. From a directional perspective, ADS-B is omnidirectional. It gives you a spherical look at all of the aircraft around you. Often cameras, radars will have a small, narrow field of view where that will require you to implement multiple cameras or radar systems on board your aircraft, driving your aircraft size up in order to carry that radar on board. ADS-B receivers can also track significantly more potential threats than a lot of other technologies like radars and cameras, whereas you can track 100 or more aircraft with our products, and a typical radar and a camera is 1 to 5. Hopefully you're not flying in an environment where you have to monitor 100 nearby threats. Maybe you shouldn't be flying in that case, but you do have that capability. It gives you the ability to strategically deconflict and not worry about a close range collision avoidance maneuver. So if you've got a strategic deconfliction, you can see the aircraft far out and adjust your flight path accordingly. Significantly lower size, weight, and power compared to other detect and avoid technologies here as well. The Ping RX Pro is a 32 millimeter sized piece of equipment. The other dimensions here are some of the onboard radars that are in the market today. So significantly less size, and ADS-B technology tends to consume milliwatts of power versus watts of power like some of the other systems. And because of all of these reasons, many OEMs and drone manufacturers are incorporating ADS-B receivers, ADS-B in, to their platforms directly. The most notable in the center is DJI. They have a technology they have termed AirSense. They have committed to incorporating ADS-B in on all of their new platforms from this year forward that are greater than 250 grams. That's a significant number of drones that will be listening for you if you're flying. And there are a couple of other examples. On the right, you've got a Skydio X2. On the left, you've got one of the more popular autopilots, the Cube Pilot, where we have incorporated our ADS-B receiver into that platform as well. So these companies have recognized the global applicability of ADS-B reception as a detect and avoid technology, making it more and more important, or bringing another safety benefit to using ADS-B on unmanned aircraft. So we like to say what that means is ADS-B is drone repellent. So if drones are listening for ADS-B signals, if you've got ADS-B on your aircraft platform, then they will see and avoid you. A little bit about ADS-B in the United Kingdom right now. I mentioned electronic conspicuity earlier. Electronic conspicuity strategy was updated by the CAA and has been communicated since May of this year with an updated deployment vision by January 2024. What they've stated is, where required, every airborne vehicle and system in the UK system will broadcast a standard electronic conspicuity transmission on one of two common frequencies that are protected and reserved for aviation. This is a clear direction by the UK CAA, and I commend them heavily, that they will be incorporating ADS-B into their airspace plans in the future, both for manned and unmanned aviation. Another really interesting thing here is they are planning to adopt the use of 978 megahertz as a second ADS-B frequency. The primary ADS-B frequency is 1090 megahertz. That's globally used. 978 is used primarily only in the United States today, but the UK is moving towards incorporating that in their plans in the future. The objectives of that electronic conspicuity strategy: one, to enable the safe and efficient integration of unmanned aircraft systems within the UK airspace. Right away, objective number one is not just about general aviation, it is about integration of drones in the airspace using electronic conspicuity. Two, help mitigating the risks of mid-air collision. If everyone is transmitting and receiving on common interoperable standards, then we can all see and avoid each other. And three, enable the ongoing modernization of the UK's airspace structure, bringing it in line with global modernization of airspace through ADS-B implementations. CAP 1391 is the UK's document that describes what an electronic conspicuity document is, or a device is. It is a device based on ADS-B. Very simply, the device is a technical specification for how electronic conspicuity devices should work, what power they should output, what frequency they should output, what parameters they should output. The UKCA was very, very forward thinking in defining a low-cost ADS-B standard. Typical ADS-B equipment that gets installed in aircraft can run thousands of dollars, and they defined a standard that can bring that down to hundreds of dollars in order to make it a more affordable and safe airspace. General aircraft owners who have no requirement to equip with traditional transponders can voluntarily equip with an EC device, and they can be portable, so they're very, very low cost. CAP 1391 enables that key functionality necessary to progress and deploy the EC strategy. It does leverage specific international and European standards, but the progression of CAP 1391 is spreading. Australia have adopted CAP 1391 standards, so they are now also allowing portable ADS-B devices. EASA is watching very, very closely and plan to expand use after a period of time. Challenging specification from a manufacturer's perspective. It is not easy to be committed to broadcast on a protected aviation spectrum. You have to have some credentials and performance of your system. So it is, while it is a low-cost system, it is not an easy technology to achieve. And we understand and are working with the UK CAA for future additions and future modifications that will make this a broader standard that will bring more interoperability and better performance out of the overall system. Right now, as closing, there is a rebate scheme, so free money from the UK CAA and Department for Transport. There's a $250 rebate on electronic conspicuity devices, including the Sky Echo and Ping 1090i devices that are being offered from the UKCAA and Department for Transport. So if you purchase one of these devices through the end of February, you go onto the electronic conspicuity website for the CAA, you fill out your form, you submit your proof of purchase, they'll send you a check for £250. This is about half the cost of Sky Echo, and the Ping 1090i is a bit more expensive. So it's not quite as large from a percentage perspective, but it is a great technology for your drone application. I think I hit most of those targets. So the scheme is open until March 31st or until all of the funding is used up. They anticipate that about 10,000 rebates are available. So kudos to the UKCAE here for expansion and encouragement of electronic conspicuity. The requirements to apply, I talked through those already, but you know, buy an eligible device. If you go to uk.caa.gov/EC, you'll find more about the rebate scheme. And that looks like that's about it. My time is up, and please reach out to me either on the chat box or through the email address you see on your screen. And thanks everyone for listening, and please check out our website, www.uavionics.com. We've got lots and lots of cool technology there for drone and general aviation technologies. So thanks again. And Emily, thank you very much.